So here is my presentation on fatigue and recovery 2.3 assignment. So let's start off by defining what the word fatigue means. Fatigue is the extreme feeling of exhaustion and decreased capacity to complete physical or mental work. There are three types of fatigue. We'll start off with the first one. The first one is a local fatigue. And this type of fatigue is situated in the muscles and is caused by repeated contractions without recovery. So as you can see from the picture that I've included, you could see a man is deadlifting, so repetitive deadlifts could lead to local fatigue. The second type of fatigue is general fatigue. This type of fatigue is described as either post-training fatigue or psychologically feeling weak. So how do I say? So pretty much sometimes after your intense exercises, you may feel exhausted. So that is due to general fatigue kicking in. And then the third type of fatigue is called chronic fatigue. And this type of fatigue takes place when you overtrain or you've lacked in recovery, which results in a weakened immune system. So as you can see, I've used an example of a man just sleeping on some books, which just shows that he may have not recovered very well from the night before. He may have gone out running and he didn't get the right amount of rest. So in this PowerPoint, I'll be covering three of the systems. So I'm going to be covering the ATP-PC system, the lactic acid system, and the aerobic system. But I'll go through them one by one. So we're going to start off with the ATP-PC system. So an analysis of the ATP-PC system. This system is started off when ATP is broken down into ADP via the process of hydrolysis. This releases energy for muscle contraction, and muscle contraction results in movement. Fuel and waste products. So the fuel for this system would be phosphocreatine, and the waste product would also be phosphocreatine, which is a non-harmful waste product. Solutions to reduce this type of fatigue. So we would usually do PC supplementation before an exercise to reduce this type of fatigue. So after exercise, you need time to recover from a certain activity. This allows you to use oxygen from the aerobic system to resynthesize ATP and PC. However, in order to delay fatigue, you can take PC supplements before your physical activity. Taking PC supplements will increase PC stores, resulting in an increase in duration of performance and a decrease in recovery time, and it also, most importantly, delays fatigue. So what is the Wingate test? I've decided to use the Wingate test for this system as a test for as an example for this system. So the Wingate test is an anaerobic exercise which is performed on a stationary bike, and it measures anaerobic power and aerobic capacity. It involves you pedaling for a set time at a maximum speed against a given resistance. You'll be using your fast twitch fibers due to the exercise being performed at a low duration and high intensity. So as you can see, I've included a graph and I've included two new names here. So the first new name is O2 deficit, or also known as oxygen deficit, and the other one is EPOC. So I'll go through them both. So let's start off with what EPOC is. So EPOC is excess post-exercise oxygen consumption, which is also known as the recovery process, if you want to simplify it. And the O2 deficit is the oxygen that we would have used if it was available. So due to this exercise being anaerobic, you won't be using any oxygen, so the O2 deficit on the graph would be a lot larger than it is. So the EPOC is broken down into two stages usually, but in this case, because this exercise is anaerobic, it's only broken down into one stage. But I'll name the two stages. The the two stages are usually called either the fast component of epoch or the slow component of epoch. Now, if you would like to use the scientific words for this, you'd have to say the fast component is the lactic acid, and the other one is alactic. So the alactic is fast recovery of epoch, and the lactic acid is the slow recovery of epoch. Now, due to this exercise being performed at a anaerobic intensity, or anaerobic, it's an anaerobic exercise, you won't be using any oxygen. So the oxygen depth would be quite high. So the fast recovery would pretty much cover the whole of the recovery process. So alactic recovery would kick in, and the aerobic system would be used because the oxygen would come in and be delivered to your working muscles. So here's a slide on the lactic acid system. So we're going to start off with the analysis of the lactic acid system very quickly. So the lactic acid system is started off by glycogen being converted into glucose via the process of glycolysis. Glycogen being converted into glucose releases two molecules of ATP, and as we know from previous assignments, ATP is the main energy source for muscle contraction. Glucose is then broken down into pyruvic acid, which is also known as just a weak acid. The pyruvic acid is then converted into lactic acid, apologies there, by its enzyme lactate dehydrogenase. The fuel for the lactic acid system is glycogen. Now, this system isn't exactly the same as the ATP-PT system in terms of waste products, because in the lactic acid system there are harmful and non-harmful waste products, whereas in the ATP-PT system there is only one waste product, and there's only non-harmful waste products. So which is phosphocreatine. But in the lactic acid system, you've got both. So the harmful waste products of the lactic acid system are obviously lactic acid and hydrogen ions. But the non-harmful waste product, there's only one, and that is carbon dioxide. So after a moderate exercise, you may feel slightly sore and feel some pain in your muscles. This is due to lactic acid accumulation. Lactic acid accumulation Lactic acid accumulation is when lactic acid can build up in your bloodstream faster than you can burn it off. All of this is due to lack of oxygen. Hydrogen ions can also build up, which raises the acidity, or if you would like to say, lowering the pH of your bloodstream. These factors affect performance negatively by slowing you down and making you tired. In other words, it makes you fatigue. This type of fatigue is known as general fatigue. Now, something I didn't mention in the other slide was RER. Now, RER stands for Respiratory Exchange Volume Ratio, and it is the ratio between the amount of carbon dioxide produced in metabolism and oxygen used. Because one of the waste products in the lactic acid system is CO2, then the respiratory exchange volume ratio is related to this. Because the lactic acid system is used at a moderate intensity, only a moderate amount of carbon dioxide is made. So the CO2 production against the O2 uptake, the CO2 production would be large there would be a large CO2 production O2 uptake ratio. So I have decided to use the lactate threshold test as an example of an activity that would use the lactic acid system. Now, the lactate threshold test tests the speed at which your body absorbs lactate. The faster your body absorbs lactate, the fitter you are. If your muscles are producing lactate faster than your body is removing, you're performing at a relatively high intensity, and this is where fatigue starts to kick in. Now, after some strenuous exercises, you may feel some stiffness and pain in your muscles. This is referred to as delayed onset muscle soreness, or DOMS, as I've put here. So as you can see, I've included a picture here, or just a timescale of someone. So they've had an intense workout on day 1. Day 2, they're calm, they're all relaxed. And day 3, it just suddenly comes and then starts to make your muscles feel incredibly sore from the workout that you had a couple of days ago. This is known as DOMS. So as you can see, I've included 2 graphs here, but we'll deal with them one by one. So first graph, as you can see, there are 2 lines, one representing an untrained person, the other representing a trained person. And it is a graph showing blood lactate concentration in millimoles, and then it's against work rate, which is in watts. So pretty much it basically shows that as the work rate increases, the blood lactate starts to increase, but only at a certain point. So the later your blood lactate starts to gradually increase, the fitter you are. And as you can see, at 4 millimoles, blood lactate concentration is where we call OBLA, and that is also known as onset blood lactate accumulation. And pretty much it just shows that the trained person comes up and their OBLA is at 4 millimoles at a later time than the trained person. And OBLA is when then you start to become less able to complete the activity, and fatigue starts to gradually kick in, stronger and stronger, and then after that you would definitely need some recovery time. But as you can see, these two just carry on, and probably their work rate would start to have to decrease soon in order for them to recover. Now here is the second graph. And it's basically the same image as the first one, because I wasn't able to get hold of efficient data for the lactate threshold test, but I'll explain it anyway. As long as we've got the diagram, I'll explain it anyway. So during recovery from this test, you would use your aerobic system, because it brings oxygen into your body to get rid of the lactic acid that has been built up. During this test, you will create an oxygen deficit for yourself. An oxygen deficit means the oxygen you would use if it was available. And during the lactate threshold test, the oxygen deficit would be pretty large. So the more anaerobically you work, the larger your oxygen deficit is on the graph, because you're not using a lot of oxygen. You're not using oxygen during when you're using the lactic acid system. At the end of your exercise, the line on your graph will start by rapidly decreasing and then slowly decreasing. So on this graph, it might not seem as clear, but at some point during the recovery stage, it rapidly decreases, then starts to gradually slowly decrease. This stage is known as EPOC, also known as excess post exercise oxygen consumption. Some people may refer this to as the recovery phase, but scientifically it is called EPOC. The more anaerobically you work, the larger your EPOC size is. There are 2 stages to EPOC: the alactic recovery, which is also known as the fast component, which is the start of EPOC, and the lactic acid recovery, also known as slow recovery to EPOC. So now we move on to the final energy system of the assignment, which is the aerobic system. The aerobic system is the only system that uses oxygen during exercise. Its energy sources are fat, glycogen and protein. We get these energy sources when we consume these types of foods. We produce harmful and non-harmful waste products when using this system. The harmful waste products are lactic acid and hydrogen plus ions. The non-harmful waste products are carbon dioxide and water. Glycogen stores are vital during long duration exercises because they are the primary fuel for our muscles. Long distance runners, like marathon runners, take this one step further by carbo loading. The purpose of carbo loading is to increase glycogen levels, which delays fatigue. Here is a way of carbo loading. So 7 days before a race, this takes place. The first 3 days, you train hard, but you have a low carb diet. The final 4 days, you reduce exercise levels and eat a very high carb diet. This results in forcing your body to store glycogen, which is also known as supercompensation. The respiratory exchange volume ratio would be high in terms of carbon dioxide produced due to the duration of the activity being long, and it is high in terms of oxygen used due to working aerobically. So sometimes during exercise, when our glycogen stores run out, our fat is used to provide us with energy. Fats from foods are broken down into fatty acids, which travel to the blood and then are captured by cells. These high energy fatty acids provide us with energy, but it may take a while as they need to be broken down first and then transported to the working muscles. Now, during the sliding filament theory in the neuromuscular system, the role of calcium ions is to bind to troponin in order to clear the sites on actin, which allows myosin to grab onto the sites of actin, resulting in the whole myofilament sliding across. This is the start of muscle contraction during any type of exercise. A low amount of acetylcholine would lead to fatigue due to low amounts of acetylcholine arriving at receptor sites and muscle contraction not being able to take place. Now, for this system, I decided to use the VO2 max system, and this test determines an individual's oxygen consumption. During a VO2 max test, you run at your preferred submaximal pace for approximately 10 minutes on a treadmill or on a stationary bike. You'll be doing this test while having a mask on your face in order to measure your CO2 production and O2 consumption. So during the exercise, the more oxygen you use, the fitter you are. During the test, your VO2 max, or which is also known as your maximum oxygen consumption, is determined whilst looking at your VO2 max graph. Wherever the graph starts to plateau is where your VO2 max is. Now, the epoch size would be relatively low because you wouldn't need to use as much oxygen, because during the exercise you were already using oxygen. The two types of epoch, so the fast component, the alactic, would be a lot less, and the lactic acid, or the slow component, would be less as well.